Since the fall of 2017, the University of Richmond has been working on an ecological corridor, the Gamble's Mill Eco Corridor. The development has included removing invasive species, restoring Little Westham Creek, and realigning and paving the Gamble's Mill Trail. Another major aspect of the eco corridor's creation is planting and maintaining native flora, including native trees. Trees act as a sink for carbon dioxide by fixing carbon during photosynthesis and storing carbon as biomass, and therefore, trees are very, very important in the process of carbon sequestration, which is instrumental in slowing climate change resulting from the release of greenhouse gases, including carbon dioxide. We sampled trees in the eco corridor to determine how much carbon sequestration our sampled trees provide.
Right here, it's not even that bad.
I mean, you're not going to make it if you jump.
Hey!
Our project is actually an extension of a pre-existing study. Other classes had already started inventorying the eco corridor's trees ever since its restoration in 2018 and 2019. We've been adding to their data and inputting it into an online database called ArcGIS, where it's stored for others to reference. For each tree, we used a special measuring tape that's specifically designed to measure an object's diameter.
And we are going to call that 65.7.
Then we took a tree tag and nailed it into the trunk, making sure to consistently place the tag number on the north side of the trunk so others could easily find it.
Are we going to tag it?
Yeah, it's going to be 136.
Okay.
We also measured the tree's height using one of two methods. One way was to use a tangent height gauge and a very long tape measure. To use the gauge, you look at the top of the tree through the viewing holes while keeping the level bubble centered. Then you measure from the base of the tree to your position and up to your eye level, and this gives the tree's height. But this requires you to walk quite a distance, making this process tedious since often we were in locations with little to no flat open areas that provided clear sight of the entire tree. So when we could, we used a laser which calculated the tree's height with just a couple of button pushes.
29 meters.
We input all of our data into the ArcGIS app alongside the other classes' data where everyone can view it. In addition to the measurements we took, we also recorded whether each tree was alive, its location, the date tagged, its tag number, and who tagged it. We exported all of our data to Excel, where we analyzed the trees and their carbon sequestration rates.
Using an equation derived from previous research on our topic, we were able to determine the total carbon sequestration of all the trees we logged in the eco corridor to be 742,004.57 kilograms of carbon dioxide. We were able to get this value by using the diameter at breast height in centimeters and the height in meters of each tree we measured, and then determining the tree's biomass and carbon dioxide content. Key values from our data analysis include the average DBH of a tree at 63.48 centimeters, the average height at 25.2 meters, our most common species and species with the highest average sequestration, both being oak, and the average sequestration for any one tree in the eco corridor being 8,883 kilograms. This shows that the eco corridor plays a vital role in mitigating the carbon footprint at Richmond.
And lastly, we'd like to extend our sincerest thanks to Taylor Hurtado, Beth Zazamia, Dr. Jennifer Seven, and Valerie Galati for helping us along the way.
What are we doing, Charles?
We are taking the DBH and height of these trees. Noelle's over there with the laser thing.
What are you doing over there, Noelle?